What's up, guys? I'm going to show you guys how you can approximate pi using fractions. So, you may have been taught in high school that 22/7 is 3.14, right? Well, it is. 22/7 is 3.142857. I was just about to say 1, but it just goes 2. This is like 0.001 off. And this is still pretty close to pi, but if you do it with more complex circles or something like that, if you're gonna measure a circle that's like the size of this poster right here, then you maybe be like 1 off or something. So there are better approximations, like 355 over 113. On episode 37 of the series, I discussed cyclic numbers, and 113 is a prime number that conforms, something like this. I talked about this approximation as well, but I want to talk to you and dive more into approximations of pi. So, anyway, this equals 3.14159292, and it stops there. Well, there are more digits, but I just don't remember them. This is extremely close to pi. This is just a nice slice of pie. This is 0.000001 off, I think. Wait, it's 0.000007 off. So it's insanely close, but if you were to measure something as big as my room, then it would be like 1 off. But pi is also hidden in some approximations, like start with 71. It's a prime number. And some of these approximations I got the idea from Vsauce's second channel. And it was where one of his other guys that he works with decides to talk more about math and stuff. And start with 208 over 71. And what you do next is you do plus or minus 15 over 71. Plus 15 over 71 is the one I want to talk about because it gives you 223 over 71, and that equals 3.1408. Pretty close to pi. But minus 15 over 71, it gives you 2.718, which is close to Euler's number, E. So we have pi in E, and pi plus E equals pi. Yeah, so Vsauce 2 made a video discussing this, but it's just too good to leave off of here. Same thing for the next one I'm about to show you. This one I'm about to show you is another thing that Vsauce 2 talked about, and it was 684 quadrillion 912 trillion 110 billion 217 million 988,900. It just looks like a very big number, don't you think? Well, it's a perfect square, and you can find other perfect squares that add up to it in a right triangle, which can form stuff like that. And what you do next is you take this number and let it equal c squared. Yeah, you let it equal that. And for b squared and a squared, well, b squared will be 63 quadrillion, 11 trillion, 687 billion, 29 million, 178,944. And a squared will be 621 quadrillion, 900 trillion, 423 billion, 188 million, 809,956. What you do after that is you take the square root of each of these terms, and I already done it. You get A, B, and C, and I just labeled the triangle with each of the side lengths and drew it for you. So C is 827,594,170, and B is 251,021,288, and A is 788,606,634. But watch what happens if you take the ratio between A and B. You get an extremely close approximation for pi. You get 3.14159,265, which is extremely close to pi. Just hidden in this right triangle with a gigantic hypotenuse of 827,594,170, which I think is pretty neat. But it wouldn't be a huge triangle if those side lengths are measured in femtometers or something. But those are just rational approximations for pi. And we'll talk about irrational ones in the future, but those are pretty close approximations, but that is until you realize that you're going to need only 40 digits of pi to calculate the circumference of the observable universe. And I know the first 325, so 40 is enough.